Okay, good morning everyone. Today's class we are going to discuss about A to D converters, okay, analog to digital converters. See how many types of A to D converters are there here. Counter type A to D converter is there, single slope A to D converter is there, dual slope A to D converter is there, and successive approximation A to D converter, and also flash type A to D converter is there. So here the word A indicates analog, D indicates digital. So analog to digital conversion is there. So once I would like to describe the signals, what are the analog and what are the digitals. Once see here. So this is the analog signal and this is the digital signal. Okay. So here the digital signal having only two levels, that is 1 and 0, 1 and 0. 1 is indicated as high and 0 indicates low level. But analog signal having either continuous increment or continuous decrement. So the amplitude of analog signal is continuously varied with the time period. But digital never varied. It having only two levels. One is high level, other is low level. Even though the time is increased, the levels are only two. The levels are not changed, high level as well as low level. So here the high level is considered as power supply and the low level is considered as ground. Okay, and now see in analog signal, okay, in analog signal the amplitude must be either may be increased or may be decreased, either may be increased or may be decreased. It continuously varied with the time period, so that there is a need of conversion of analog to digital. Why? Because this continuous changing signals cannot be understood by the system, computers. Okay, but these signals can be understood by the human being, and only the analog instruments will measure all analog parameters in the world like pressure, temperature, flow, humidity, moisture. All parameters are only analog parameters. Why? Because all these parameters, for example temperature, the temperature may be increased or decreased for every second, whether it may be room temperature or surroundings temperature or whatever it may be. Every time the temperature must be increased. And like water flow also never maintains constancy. Fraction of second at least there, for every second there is a small increment or decrement. River flow is there, river pressure is there, river water pressure. So like that in surroundings, all parameters, pressure, temperature, moisture, humidity, viscosity, all these are analog parameters only. So the instruments whatever they used for measuring these parameters, okay, give the values in analog form only. But if we are to store these values for the future purpose or for the better improvement of the values or to for the understanding of human being, we are processing these analog parameters with computers. But the computers are unable to understand the analog signals. Okay, computers are unable to understand the human signals. The computers can understand only the digital signals. Computers can only understand the digital signal. Why? Because the digital signals having only two levels. One is high level, other is low level. This high level is termed as binary bit 1 and this low level is termed as binary bit 0. That's why, because of the system understand only the machine language, binary language, that consisting of only zeros and ones, and here our digital signal gives that values only zeros and ones, so that the system can understand only the binary number system, and it is easily access the digital signal. Why? Because digital signal is an indirect indication of binary levels. Okay, and here now our analog signals can be measured by the analog instruments or measuring instruments, and these can be converted into the digital for the sake of system to process these signals. The system can understand only the binary language, so that there is a need of converting of analog signals into the digital signals. Okay, what is meant by analog signal? The amplitude of these signals must be continuously varied with the time period. Either there will be an increment or there will be a decrement, continuously changed with the time periods. And while coming to the digital signal, it having only two levels, high level and well as low level. High level, low level. High level means all indicated with binary bits 1 and low level all are indicated with 0. Okay, and see here, while coming to the types of analog to digital converter, 6 types are there. Counter analog to digital converter, single slope A to D converter, dual slope A to D converter, successive approximation A to D converter, flash A to D converter, and tracking A to D converter. But among 6 converters, our syllabus having only 2 converters, counter type A to D converter and successive approximation type A to D converters. Okay, among 6 converters, only 2 are there in our syllabus. What are the 2? Counter type A to D converter and successive approximation type A to D converter. Is it clear? So now first I would like to explain you about counter type A to D converter. See, this is the block diagram of A to D converter. So once listen carefully the construction and operation I explain with the help of diagram only. After explaining it with diagram, once you see the slides. So see, in construction it consisting of 4 main parts. So how many number of blocks are there here? Mainly 4 main blocks are there. Okay, what are the main blocks? Once see here. So first one is our comparator. First one is our comparator. Second one is our AND gate. Third one is our BCD counter. Fourth one is D2A converter. How many number of important parts are there? 4 important parts are there. What is the first one? Voltage comparator. Second one, AND gate. Third one, BCD counter. Fourth one, D2A converter. So total 4 are there. Voltage comparator, AND gate, BCD counter, D2A converter. Okay, and see, while coming to the operation, okay, in construction it consisting of 4 blocks: voltage comparator, AND gate, BCD counter, D2A converter. And what is the function of voltage comparator means? Here it will compare the measured input voltage. It will compare the measured input voltage with the output of D2A converter. Measured input voltage with the output of D2A converter. And the AND gate will produce the clock pulses to the BCD counter. AND gate will produce the clock pulses to the BCD counter. And this BCD counter will allow the clock pulses, okay, and it will count the clock pulses. If it will count one clock pulse, it will give that count in binary value. If it count one clock pulses, it will give that count in binary 1. If it will count 2 clock pulses, it will give that count in again 2 binary value 0 0 1 0. If it will count 3 clock pulses, it will give that 3 in binary form 0 0 1 1. This is the function of BCD counter. And last one, D2A converter. It will convert the given or achieved digital pulses into the equivalent analog voltage. The D2A converter will convert the received digital inputs into the analog form. Now again this voltage comparator will compare the input voltage with the output of D2A converter and produce the output voltage. Okay, so in this way this process is continued until and unless the power supply is switched off or the input voltage given to the comparator is switched off. Is it clear? So now say, while coming to the working or operation, if the input voltage whatever is applied to the comparator, means before going to start comparison, you should do one initial setting. That is, first you should reset the counter. Means initially the counter values are only 0 0 0 0. First you should reset the counter so that the output of the counter is 0 0 0 0. Is it clear? First you should reset the counter so that output of the counter is 0 0 0 0. After resetting the counter, now you should apply the input voltage across the voltage comparator. So cause of resetting the counter, the digital values are 0 0 0. So now the D2A converter getting only the 0 0 0 0, and this voltage V0 is equal to also 0. At that moment when V0 is equal to 0, when the output of D2A converter is 0, at that particular moment only you apply now VA. So now when VA is greater than that of V0, now I applied my voltage, whatever the voltage I would like to convert into digital form is now compared with V0. If VA is greater than that of V0, now the comparator will produce one pulse to the AND gates. Now the AND gate acts like a short circuit and allow one pulse to the counter. Now the counter count one pulse and give the value of 0 0 0 1. And now this digital voltage 0 0 0 1 is converted into the analog voltage with help of D2A converter. Okay, now the D2A converter will convert this 0 0 1 1 into analog voltage, and equivalent analog voltage, either it is 0.5 volts or 165 volts, is now compared with our input voltage again. If VA is equal to or VA is greater than that of V0, now the voltage comparator will produce one more pulse again, and again this AND gate acts like a short circuit and allow the second pulse. Now the counter will give the value of second pulse in 0 0 1 0, and again the D2A converter will convert this 0 0 1 0 into equivalent analog voltage, whether it may be 1.625 etc. Now our comparator will again compare this input voltage VA with V0. Again, if VA is greater than 0, voltage comparator will produce pulse and AND gate acts like a short circuit, and it will allow the clock pulses to the counter. Again the counter start. So when it will stop counting? When the VA is less than V0. If VA is less than V0 will be achieved. If VA is less than V0, that means the output of analog converter is greater than that of the input signal. Now the comparator provides a low level signal. The comparator provides a low level signal to the AND gates. When the AND gates will receive low level signal, automatically it acts like a open circuit and it will not allow the clock pulses, and now the counter stops counting. So when it is achieved, cause of it is a 4-bit counter, after 15th clock pulse, at 16th clock pulse, the voltage VA becomes less than that of V0. Automatically the voltage comparator produces low level signal. Cause of AND gate getting low level signal from the comparator, now the AND gates will act like a open circuit. Cause of it is open circuit, the clock pulses are unable to reach the BCD counter and the counter stops counting. Now the output voltage again is equal to 0. Means what is the capacity of this counter? This counter will count the pulses from 0 0 0 to 1 1 1 1. In decimal it is equal to 0 to 15. Only 15 pulses. That means the analog voltage is converted into the digital. So final output of A to D converter is all ones, that is equal to 15. Is it clear? So this is the construction and operation. Once check the slide. what I explained, it is there in the slides. Once see the slide. It consisting of what? Voltage comparator, BCD converter, D2A converter, as well as AND gates. Okay, voltage comparator, BCD converter, D2A converter, AND gate is there. Okay, and voltage compares the incoming voltage, that means input voltage, with the output from the DAC, digital to analog converter. Okay, and welcoming to the next one. Our next one is what? D2A converter. Already I told you, it converts digital signal to analog. BCD counter, count the numbers from 0, 0, 0 to all ones. And initial setting, already I told you, first you reset the counter. First, what is the first prime function of A to D converter? Resetting the counter. After resetting the counter, then you apply the analog input voltage to the comparator. Before resetting, you never apply the input voltage. After resetting, after getting 0, 0 across the counter only, we have to apply the analog input voltage. Okay, and while coming to the operation, already I told you, if VA is greater than 0, the output of comparator switches to high states. Okay, if VA is greater than 0, the output of comparator switches to high state and enable the AND gates. When the AND gate is enabled, it acts like a short circuit and it will allow the clock pulses. Now the counter continues to advance from one binary state to other according to the number of clock pulses it received. Okay, and next one, if and the count is displayed as D3, D2, D1 as already told. And when next case, when VA is greater than V0, the comparator output is high, but when V naught is greater than VA, if it reverse, when V naught is greater than VA, that means VA is less than V0, the comparator output goes low and disable the AND gate. If the AND gate is disabled means what? It is open and it will not allow the clock pulses. Automatically the counter stops counting. Okay. So this is the operation of what? Our counter type analog to digital converter. And see here, one most important point is there. Here the counter, after resetting to 0, the number of clock pulses required for conversion is how much? 2 to the power of n. Here it is a 4-bit converter, so 2 to the power of 4, 16 clock pulses are required. So this is the graphical representation of our A to D converter. And while coming to the advantages, it having simple construction, economical, but more one disadvantage is there, that it becomes less speed, having less speed. The conversion time varies, depends upon the analog voltage, and the number of clock pulses required for conversion is 2 to the power of n. It requires much more clock pulses for working. Okay, and see, while coming to the next topic, next converter, that is successive approximation type analog to digital converter. Successive approximation type digital to analog converter. Okay, so here how many number of main blocks are there? Here also it consisting of 4 blocks. What are the 4 blocks? 4-bit D2A converter, voltage comparator, control, and also successive approximation register. And while compared to the counter method, 2 blocks are same and 2 blocks are replaced. Here voltage comparator and 4-bit D2A converter are same, but here AND gate is replaced with control and successive approximation is replaced by the counter. Means counter is replaced. In counter method their BCD counter is there. Here that is replaced with one register, that is called successive approximation register. Here one control is there, counter control. Okay, and see, while coming to the operation, whatever the voltage you compared, that must be applied initially. Before going to that, you should reset the register. Okay, first you should reset the successive approximation register, so that again all the values D0, D1, D2, D3 are is equal to 0. Okay, according to the digital input 0, the analog voltage V0 is equal to also 0. Initially, first you reset the successive approximation register, so that we are getting output D0, D1, D2, D3 is 0, and also V0 is equal to 0. Okay, so when we are getting V0 is equal to 0, at that moment you applied your converted analog input voltage. Whatever the voltage you would like to convert into the digital, that is considered as input value. So whatever the voltage you would like to convert into digital is called input value. So now you applied input voltage across the voltage comparator, input value across the voltage comparator. When the successive approximation is reset, that means when the 4-bit due to A converter is 0, at that moment only you apply the input voltage. Now our comparator will compare VA with V0. If VA is greater than that of V0 only, it will produce one pulse to the control. Okay, when we will apply or when we will produce the high level, VA is greater than V0, now the voltage comparator will produce high level pulse to the control. Now the start button will be activated and it will allow the voltage to the counter, and it will produce binary bits. Now the successive approximation register will produce it into the D2A converter and outputs. Here this controller is simply like a counter type in our AND gates. Okay, and while coming to the next one, again if VA is equal to V0, this voltage is compared with reference voltage again, and it will produce the output voltage. Only when VR is less than VA, at that moment it will stop counting. Till that it will produce the pulses and the counting is going on. Okay, and see here in slide, whatever I explained, that is only there in the slide. Successive approximation A to D converter consisting of what? Main blocks are voltage comparator, successive approximation register, D to A converter, control logic, and buffer register is there. Okay, voltage comparator, successive approximation register, D to A converter, control logic, and buffer register is there. Okay, and while coming to the next one, already I explained you all the things. Voltage comparator. So now our voltage comparator will compare the voltage coming from the digital to analog converter and analog input voltage. And here our D2A converter will convert digital signal to the analog signal. And the successive approximation register, the successive approximation register is a register where the output is 1 0 0 0 initially. What is the initial output of successive approximation register? 1 0 0 0. And see, while coming to the control logic, the control logic sets or reset the successive approximation outputs, depends upon the comparator output. So here our control logic either will set or reset the successive approximation, depend. If the comparator will produce high level output, it will set the successive approximation register. If comparator produce low level outputs, the successive approximation register is resetted. So when the comparator produce high level outputs, if VA is greater than that of V0, comparator will produce the high level pulse and the successive approximation register will be in set condition. And if VA is less than V0, comparator will produce low level pulse and the successive approximation register is in reset condition, Okay, if VA is greater than 0, the comparator would produce high level pulse, the successive approximation register is in set condition. And see the slide. If VA is less than V0, comparator will produce low level pulse and successive approximation register is in reset condition. Okay, is in reset condition. And see, while coming to the output buffer, simply it will provide the output to the actual digital outputs. Already I told you what are the initial settings here. Initially the SAR is set to 100. In previous one a BCD counter is reset, but here it is set. Okay, there the counter is resetted, here the successive approximation register is in set condition. That output of counter is 000 in previous one, here the output of successive approximation register is 1000. Okay, when the DACs produce the output voltage V0 is equal to VR by 2. So after applying the analog voltage as input to the comparator, the control logic sets the MSB if the output of the comparator is positive, else it will reset the MSB. Already I told this. And then for the next lower significant bit, it is set to 1. So now the DAC output is either 3VR by 4 or VR by 4. So this process is continued until the LSB bit is checked. See here, this is the illustration diagram. In diagram, once you see, here first bit is what? 100. So some unknown bit is compared with this one. If this unknown is compared with this one, if it is greater than, you follow the like this, and again if it is less than, and the comparison is like this. Okay, if it is 0 1 0, it is compared with 0 0 0 like this. If it is 1 0 0, 2 ones in the input, it is compared with 2 ones. Okay, see here 0 0 0 is compared with 0 0 1, 0 1 0 is compared with 0 1 1, 1 0 0 is compared with 1 0 1, 1 1 0 is compared with 1. Means each bit is compared with their succeeded bit, means they succeeded bit, next bit. 0 0 is compared with 0 and 1, 0 1 0 is compared with 0 1 1, 1 0 0 is compared with 1 0 1, 1 1 0 is compared with 111. In this way, first bit is compared with the second one. If second is compared with the third one, third is compared with fourth one, until the comparison is done, until the pulses are is equal to the applied input voltage. Okay, and see here all the n bits are determined after n cycles of V0 generation and comparison with VA. Here the buffer register output provides the actual digital output. All the n bits are determined after n cycles of V0 generation and comparison with VA. Buffer register output provides the actual digital output. Buffer register output provides the actual digital output. This binary output represents the value of the analog input. Thus, an n-bit digital output is produced in n clock cycles. While coming to the advantages, it will provide the speed of operation. The speed of operation of this converter is very, very high, and the conversion time is constant irrespective of the analog inputs. Conversion time is constant irrespective of the analog input. Okay, and here the number of clock pulses required for conversion is n. Number of clock pulses required for conversion is n. Okay, and see, next one is comparison of binary weighted resistor versus R2R ladder network. So comparison of binary weighted resistor versus R2R ladder. So here in binary weighted resistor, it is easily understand by the human being. Okay, but compared to binary weighted, R2R is complicated. Okay, why? Because here for the simplification of the circuit, Thevenin's theorem is used. Okay, and see, next while coming to the construction, okay, in process of binary weighted is PROS indicates process or procedure. Procedure of binary weighted is easy compared to the R2R ladder network, but in construction, limited 8 bits, large number of registers are used, and it is suspected to high level noise ratio, and it is more expensive, and great errors are provided. Okay, while coming to the construction, so limited bits, it requires a large number of resistors, and susceptible to noise ratio means more noise is produced, and it is expensive, cost is also very very high, and great error will be produced. And while coming to the R2R ladder, and more confusing analysis occurred. More confusion is there in R2R ladder. And see, this table gives the difference between the successive approximation register and also counting method. Okay, so while coming to the first one, resolution. So before going to resolution, once we would like to revise what is meant by resolution. So resolution indicate what? How many number of discrete steps are there in the output of analog to digital converter. How many number of discrete steps are there? Okay, so here it indicates 8 to 18 means how many number of discrete steps are there here? Because of it having 8 to 18, so here 8 to 18 discrete steps are there. Okay, what is the maximum speed? 10 mega. And what is the maximum speed of this counter method? 1 mega only. So compared to counter method and all other method, successive approximation register will give very 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 high speed. Okay, it will give very high speed. And while coming to the other advantages, it becomes very fast and it consumes low power and it is inexpensive, means cost is also less. Why? Because inside it consisting of control logic circuit is there, and SAR means one register is there, and also one converter is there, and simple comparator is there. Cause of all are simple element, it is inexpensive, economical, low cost, cheap. Okay, and also it use as a multiplexer sometimes. Okay, and while coming to the advantages of counter method, it is less susceptible to the noise. So noise is very very less in counter method, but it is more in successive approximation. And while coming to the resolution, it having very high resolution compared to all other, but not compared to the previous one. And the number of SH amplifiers are needed. So here it will require AND gates and also BCD counters now. And see here next, while coming to the applications, so it is used in data acquisition system. Okay, where it is used? It is used in data acquisition system in PLC SCADA, like industrial automation. Nowadays every industry works based on the industrial automation, that means smart technologies are developed. Okay, Arduino based technology, IMT. So there we are using our successive approximation A to D converters. Okay, and in industrial control systems also it is used. Okay, and also in battery powered systems. What are the applications of successive approximation A to D converters? First one, it is used in data acquisition system, and it is used in industrial control system, and it is also used in battery powered systems. And while coming to the next one, that is counter method, it is used in instrumentation. Okay, it is used in instrumentation. That means where we have to measure the analog parameters. Okay, where we have to measure the analog parameters to convert those analog parameters into digital. For example, pressure device is there, bellows, LVDTs, RVDTs, pressure measurement devices, or thermocouple, thermometer, pyrometer, bolometer. All these are temperature measuring devices. So all these instruments will measure the temperature and give the values in analog only. But these analog values cannot be understood by the system. Also human, if we getting it in digital value, then it is very easy to understand. Okay, but in analog it is somewhat difficult to understand. So that there is a conversion of analog into the digital with the help of this successive approximation digital and also counter method. And this audio also used in audio recorders, video recorders, and also used in medical applications, and it is also used in medical applications. These are the applications of and comparison between the successive approximation and also counter type converters. Okay, and see here some multiple choice questions are there. So nowadays every competitive examination having some digital electronic questions. First you should say one question is there: the maximum number of clock pulses required for conversion. How many number of clock pulses are required for conversion? 2 to the power of n minus 1 or n, or 2 to the power of n, or 2 to the power of n, 2 to the power of n minus 1. And see, while coming to the successive approximation A to D converter is faster in operation. Is it faster, SAR? Yeah, yes, it is very fast. Next statement, true or false statement, is it type? Successive approximation A to D converter requires D to A converters in its circuit diagram. Yeah, it is there, so that it gives true. And see, while coming to the important marks question, so our question paper long answer question carries 5 marks. For the 5 marks, they asked explain the construction and operation of successive approximation register with neat sketch. Okay, and explain the operation, construction and operation of counter method analog to digital converter. For both these two questions, the marks are divided like this. Your diagram, construction diagram carries 1.5 to 2 marks, depends upon the examiner's view. Okay, and your explanation may carry 1.5. So total 3 marks are over. And diagrams are there, graphical representation or mathematical expressions. Okay, these carries 2 marks. If any mathematical expressions or derivations are there, or any graphical representations are there, carries 2 marks. So that you focus on everything. Prepare the diagram and you explain something relevant to the diagram. That means construction, what it contains, okay, operation, when the comparison will be starts and when it will be stopped, and also if any graphs are there, you write the graphs also. Okay, and while coming to the 1 mark or 3 marks question, here are the advantages of successive approximation register, or the advantages of more one register is there now, counter method register, and also advantages of both. Sometimes they ask. And while coming to the 1 mark question, state the need of A to D conversion, first question, and define A to D converter, and what are the applications. Mention 2 applications of successive approximation register. List any 2 applications of counter method. These are the 1 mark questions. And while coming to the 3 marks questions, one important question is there: compare successive approximation register A to D converter and also counter type A to D converter. So in this way you face the different questions, 5 to 1 mark questions, and also multiple choice questions also there from our converters. Okay, multiple choice questions are like this: A to D converter will convert analog to digital or digital to analog, analog to direct or direct to analog. And sometimes they ask the questions like this: in A to D converters, D to A converters are already we watched those answers na, true and false statements like that. And what is the capacity of 4-bit R2 or ladder network? What is the capacity of binary weighted register? And they give 4 registers and they ask which one is fast: successive approximation, counter, tracking method, dual slope. So which one is faster? Successive approximation. So like that we unable to expect the questions, objective, multiple choice. So you prepared everything. Okay, So why? Because depends upon the questionnaire choice they may. So see here, you first and foremost you prepare successive approximation DAC and advantages of successive approximation, and also the applications and advantages of the counters. Okay, counter method. Okay, so this table is very important. Difference between the binary weighted and R2R ladder, and also the difference between the successive approximation and counter method. So these two questions will came for 3 marks. Give the differences between binary weighted and R2R ladder network, and give the differences between successive approximation register as well as our counter type. Okay, so these two are very important. And see here this illustration carries 1.5 to 2 marks, very important. So in your examination they are asking, it is a long answer question. First you should draw the diagram, okay, then you draw the illustration. So among these two converters, this counter type is very important. So once check the key points belongs to the counter type. So what are the main blocks of counter type? 4 main blocks are there. First one is AND gate, BCD counter, D2A converter, and voltage comparator. So what are the initial settings? Reset the counter so that output of counter is equal to 0, 0, 0, 0, 0. And after resetting the counter, what we are doing first? Apply the input voltage VA. Okay, reset the counter and apply the input voltage. These are the key points. First reset the counter so that the output of it is equal to 0, 0, 0, 0. Next you should apply the input voltage. Now the comparator will start providing the comparison between this VA and V0. If VA is greater than V0 only, it will produce the high level pulse. Now the AND gate acts like a short circuit and it will allow the clock pulses to the counter. Now the counter starts counting the clock pulses and give the value, equivalent value here in binary form. Means if it count the first clock pulse, it will give the value 0, 0, 0, 1. If it count 2 clock pulses, it will give the value 0, 0, 1, 0. If it count 1 clock pulses, the value is 0, 0, 0, 1. Now our D2A converter will convert this value into analog voltage. And now this analog voltage is compared with this VA and the comparator will produce 1 pulse. If VA greater than V0 only, the comparator will provide the pulse high level. If VA is less than V0, the comparator will provide low level pulse. If AND gate will receive the low level pulse, it simply acts like a open circuit and it will not allow the clock pulses. It will not allow the clock pulses means counter stops counting and the output of counter is equal to 0, 0, 0, 0. So when this happens, when the BCD counter output is equal to 1, 1, 1, 1, at that moment the D2A converter output is higher than that of VA, means now VA is less than V0. When VA is less than V0 occur, now the voltage comparator will provide low level pulse. When it will provide low level pulse, now the AND gate will produce nothing, means it simply acts like a open circuit. When it acts like a open circuit, clock pulses will not reach the BCD counter. That means the counter stops counting. When counter stops counting, the output of counter is equal to 0. D0, D1, D2, D3 all are is equal to 0. when D to A converter will convert this 0, we are getting V0 is equal to 0. When V0 is equal to 0, again it would like to provide start counting. VA is better. So likewise successive approximation is also same, but in place of AND gate there we are using control logic, and in place of BCD counter there we are using successive approximation register. That is only the difference between these two. And successive approximation register provides speed of operation and it will give somewhat slow operation. Okay, now I would like to conclude the class.